First, Nebula is a sub-project of Eclipse itself, and it's some kind of container for custom widgets. There you can find some date combo widgets. There's the Gantt chart, really powerful but quite buggy. There are there are some cool widgets you can use, but they're not in SWT itself. But you can add them as a project dependency, and you have new custom widgets. The same thing you have in JavaFX. I guess it's JFlex extensions or Java. I don't know. I've seen the same in Vaadin. Some custom widgets that are not in the base. And the NatTable project itself is a, well, Canoe. Some guys from Canoe had a nice word for it. It's a enterprise-ready table, but I'm coming to that. It's in the Nebula project itself. So it's an Eclipse project hosted on Eclipse, maintained by Eclipse. We're on the Eclipse build server, so we're a fully supported Eclipse project, but not in the base. And Nebula is the container for such projects. To myself, a short introduction as it should be. My name's Dirk Fauth. I'm senior consultant for the BeOne Stuttgart. Doing a lot of Java projects, Eclipse RCP related lately. And I'm a Nebula NatTable committer for about 2 years now. So I've seen the old, quite buggy versions to the current state where it is quite stable. You can contact me by email, or there's my Twitter account, or my Twitter handle, whatever it's called. So what you can expect from the next, well, for the talk, I don't know how fast we will be. The first thing is, what's NatTable in general? To give you an overview, what is this table and why is it, or how it was created, the project. How is it related to other existing JFace tables in the Eclipse ecosystem? Because you have to understand that NatTable is different than those tables, and you have to understand why because that's necessary to understand the architecture of NatTable, because it's quite difficult. And that's quite difficult. It's completely different. And we'll give you some short steps on data access in a NatTable architecture, how configuration works there, and what we have for functionality out of the box. And then I will give you some roadmaps, so to give you some hints on, we are still working on it. It's an active project. It's not a we're finished, use it or leave it. And at last, some information where you can get further information. So let's start with what's NatTable. As I started already, NatTable is a table widget. And when I introduced it to some Eclipse folks half a year ago, they just said, oh, no, not another table. Yeah, we use it, in fact, as that acronym now. But to go back in history, Nat is a addiction, or the name Nat is dedicated to the girlfriend of the initial creator, Natalie. So there's still romance in software development. And so he called his table the NatTable, and the folks who are done the evolvement of the NatTable just left the name. Today we use it as an acronym for not a table, or yeah, not another table. And in fact, it is not another table. It is a framework for creating tables, grids, and at least trees. We have a tree support in NatTable that lets you build quite confident, comfortable tables and trees. What is really important about NatTable is that it's designed to handle large data sets. And when I'm speaking of large data sets, to give you some numbers, we support max-int columns to max-int rows. So we're currently limited to the integer boundaries, which is quite a lot, I guess. Tables that have that much columns and rows are not readable, I guess. But the table was designed for the financial market. They used the NatTable, or designed the NatTable, to have a look at the stockings at runtime, how they change, and there are real big data sets with a lot of information for every stocking and everything. So this is where the NatTable originally came from. And we are providing a lot of functionality out of the box. I will give you an overview of what functionality we have there, and I have a lot of examples I will show you in this talk. Which is why one of the Canoe guys said something like, hey, this is an enterprise-ready application. This is an enterprise-ready table, more that. Because there are a lot of people out there who are saying, hey, I gotta tell you, you're giving me a table in my application, but I want functionality like I have it in Excel. I want to freeze rows, I want to sort, of course I want to filter like an automatic filter row and all of that kind of stuff. And doing this with the JFace tables or the plain tables is quite hard work. I've done that before and it's really quite hard work. Why it is quite hard work, I will show you just in a second. Here are some examples I created by NatTable. These are really in productive use. So this one is a log view at the end. If you're using Eclipse, you all know the problems view at the bottom, and there's the problem that you only have one row size. So if the text is too long, it doesn't wrap. You have to scroll or make the table larger so you can view the whole content. But the problem with the row height is that the native tables doesn't support different row heights in one table. So it is in Windows, it's definitely not possible because the window table that is used by the SWT table doesn't support this feature. So we solved this because NatTable is a custom painted table. We don't rely on the native widgets of the operating system. We are painting on a canvas, so we're completely free what to do. And this is one example where we differ from the native stuff. This is something, in my opinion, this is not possible to create with a JFace table. It is a risk matrix where the data model is a two-dimensional array. This is not possible to implement with a JFace table. I'll come to that in a second. And this is one of our favorite use cases or showcases in our examples. I will show you later on, not lately. We have column grouping there. We have a filter row. You can see with this blue line here that the first three columns are frozen there. We have background updates. And these are all valid use cases you can create with the NatTable. So you can create a NatTable that is really small for small use cases, and you can scale it up to really high functionality Excel-like applications. And it's all possible with a NatTable. Comes with some disadvantages. I will tell you later. First, I want to show you how the tables in SWT are working, or how they are designed, and what are there, which tables are there out there in my English. Okay, so we have the plain SWT tables that are going native to the operating system. We have some stacking up JFace table viewers that gives you some more possibility in styling and more comfortable API. There is a Nebula grid. It is also a grid widget in the Nebula project, but it is based on a JFace table. It was originally designed to be a bit more performant, doing some better resource management and something like that. But currently, I will show you in a showcase. In my opinion, it isn't valuable anymore because the JFace table has become quite stable and performant than the Nebula grid. Maybe there are still some features in there, but yeah, need to look at this. And there are two other tables I found on researching for this talk. There's one thing is the K table, which is also a custom painted table, but it's inactive since 2009. It was a great table widget, provided a lot of functionality out of the box also, but nobody is working on that anymore. So yeah, why should you use a widget that nobody is working on? No bugs are fixed. The JARA table is something I never heard before. It is also a custom painted table and never got a final release. And it's inactive since 2010. The last statement in the forum or on the website was, hey, have a look at K-table or at NatTable. So I guess they're not interesting anymore. Oh, and there's the Nebula X viewer to complete everything. The Nebula X viewer is also a project under Nebula, but it is especially for trees. It's extending the JFace tree viewer, and so I don't go there much into detail now because I'm relying only on the tables and on the grid for this talk. This is the typical code when you're writing a JFace table viewer for your SWT application. You're creating your table viewer, configuring some attributes, and then comes the really ugly stuff. I have to create a table viewer column for every column I want to show in my table. So if I have 20 tables, I have to create 20 table column objects. For smaller tables, this is okay, it's fine, but if you're having really large tables with a lot of columns, this is quite annoying. And it goes on, you have to configure it, every column by itself, and then you have to create a cell label provider where you're telling what to print and how to print in the table. So you have a mixing there of data and styling. And if you wanted to be able to edit this table, you have to create an editing support. So to show one column in this table, I have to create 4 objects just to have this table column editable. I'm having a showcase here. No, I want to show you the code more. This one. So this is my JFace table example for creating this little table. Yeah, just a table, 4 columns, first name, last name, a combo box, and it's an enumeration, I guess, in the model. And if you're looking at the code, I added also, yeah, it's too small, huh? I added also sorting support, so there's also a sort selection adapter every time for every column. This is a lot of code for simply showing a table with 4 columns. As you can see here, every time I have a label provider, I have an editing support. I extracted them, no, okay, other way around. Normally, these objects you're creating, or these classes, are anonymous inner classes. This is the usual use case you're looking at when you're searching for any blog posts or tutorials. I extracted them to show what it really means. Anonymous inner classes are looking nice. Yeah, my code is so much smaller and tidier, and my package structure looks smaller. But if you have a look at here, now to simply create one table with 4 columns, I have to create this. These are all classes I created to create this one table. Ugly stuff. And if you're seeing here, I'm creating in the back a data set of 10,000 objects, I guess. It was 10,000 objects. Yeah, it's half a second to create and render everything. And I added the sorting support. You can see it's not that performant. And it's editable, which is quite nice. If you remember, the blob was Wayland before. If I'm now switching to the virtual table, you can see it's quite faster. But, oh, it has updated. Why it has updated? Normally, it doesn't update because I don't have data binding in the back. Ah, OK, because it's if I'm switching it back now. Now it shouldn't update. Yeah. It updated because it was rendered. Yeah. Virtual table means you can tell your JFace table it should only render and handle the information that is showed in the viewport. So only the thing that is visible. And it's quite performant, of course, but it doesn't scale well with a lot of columns, which is, in fact, the issue related to the lot of objects you have to create for this, for every column. You can also see that if you don't care for yourself that the data is updated in the back, it doesn't update. I use the same data storage to show the values here in these tables. And they're not automatically updated in the other tables right here. There's still blob in this column. You can also see that the Nebula grid, which was the more performant option before, is now slower than the default JFace viewer. I showed it to Tom Schindel, who is currently responsible for the Nebula grid, and he was quite surprised of this result. Now, looking at the Nebula NatTable, well, okay, we're slower than the virtual table currently. I'm not sure why. Need to look at this though. But you can see we're always showing the value that is currently in my data storage. This is because of the different architecture. If you're looking at the, no, it's the next slide, I guess, if I remember it correctly. Yeah. So to repeat, in a JFace viewer, you're just connecting columns to each other, and by connecting these columns to each other, you're creating your table. And for every column, you have to create several objects or several classes, like the column object itself, a label provider, how to render, an editing support, a selection adapter for sorting, and all this kind of stuff. And you're using native OS widgets, so you're limited to the native operating system. You're not able to add functionality or behavior that is not supported by the native operating system. This was quite popular in the past, but I guess with the newer technologies like JavaFX, HTML5, this isn't an option anymore. What I wanted to say. Okay, it's the data, and this comes later on. So creating a NatTable, well, okay, I have to admit this is a really easy and a really simple showcase for the NatTable, because in NatTable we have some default layers you can use. And in this case, we're using reflection. Maybe this is the cause why we're a bit slower than the JFace view, the virtual JFace viewer option, because we're using reflection here and using the default grid layer. And then you're just creating your NatTable, and it shows my, oh, okay, I forgot the gender here in this case. But from the code, you can see if I'm having just another column, I would simply add one line to my map, and I would add an element to my property names array, and I have another column. With JFace viewers, I would have to implement another block. So what's the difference in the architecture? As I showed you before, the JFace viewers are connected column by column, or created column by column. The NatTable is more created layer by layer. So how to think about, or how to see this? You're stacking up layers, and every layer has a functionality responsibility. At the bottom, there's always a data layer who's responsible for putting the data into the table. And on the top, we have, well, if you're using a grid layer, or if you want to create a grid, you will use a grid layer at the top. If you not want to use a grid, but simply showing the inner part of a table, you will use the viewport layer at the top, who's responsible for rendering the visible part. And in between, you can add a lot of layers we are providing for column hide show, so you can right-click and hide the column, or double-click the column so it vanishes and becomes visible again. You can reorder your layers by simply drag and drop. There's a selection layer, of course, so you can select cells, rows, or whatever you have in your table. And you decide what functionality you want to support in your table by simply stacking those layers up. That's the main architecture and the main idea behind NatTable. Just stack up your layers and you have what you need. But how to get the data into the table? This is regarding to my example before from the JFace viewers. This is kind of different in the NatTable because we're not having these label providers who are having access to the viewer that can get the data with it's the content provider. Sorry, I was searching for that word. In a JFace viewer, you're using a content provider that knows about a list you want to show in that table, and then there's a lot of stuff working in the back, how to reflect those data into the table with all of these objects you have created here with the label providers and all that stuff. They get the information which object is shown in the row, and then it is transported. In NatTable, we are doing this by a data provider. So the data layer is responsible for bringing the data into the NatTable itself. And you have to put a data provider to your data layer. We are supporting a lot of data providers out of the box. But we have a two-level data access model because of to be a bit more flexible. In a second, I'll tell you more about that. So a data provider, for example, we have a list data provider. You can put a list of objects into that list data provider. So the data layer knows he has to iterate over a list to show the elements in the table. And to access the column values, you are creating a column accessor. I used a reflective column property accessor for this showcase. If you want to get more performance or want to have some different access rules, you're creating your own column accessor, which defines how to access the column values of each object showed in a row. Why we have this two-level data access model? Because using the column accessor with a list data provider is the same model I have showed you in the JFace viewer. It is row-based. You have one object per row, and you're accessing one property of your object per column. So you can't create a table that is based on a two-dimensional array, for example, because you don't have the access rules. You don't have one object for one row in your risk matrix I showed before. So there you have some other data model in the back based on a two-dimensional array, for example. Then you can just skip the column accessor and write your own data provider that is based on a XY coordinates. So your data provider, you can access data with the XY coordinates with the data provider. If you're using a column accessor with the list data provider, you're accessing a column value for each row object. And you can have these abstraction if you're using this two-level data access. One thing they were throwing some stones at me when I said this at the Eclipse Con. We don't have JFace data binding support. Okay, I have to clarify that. First, there are observable lists in data binding that support change listeners. As observable lists are implementing the collection API, of course, NatTable can handle those observable lists, and you can use your change listeners and list change listeners like before. What we doesn't support at the moment, we surely will have a look at this in the near future, is the binding of a column to a bean property. And this is because we don't have a column object. If you're looking at the data binding rules of JFace tables, you're binding the column to a property of your bean. As we don't have that column, there's nothing we can bind. So that's the situation at the moment. As there was quite rumor about this, we will have a look at this if we can have some abstraction, so you can add some data binding if that's really important to you. From my point of view, if I'm looking at the NatTable, I'm always working directly on my data model. And this is more native usage to me than creating my table, having my model there, and then creating the binding. As I'm really working on the data model, if I'm changing something in my table, it is changed in my data model. Like I've showed you here, this is my table. If I'm writing here Lisa, it is directly reflected in my NatTable, and I don't have to create a data binding for that because I changed the data model and the NatTable shows the data model directly. There's no need for data binding. Data binding also supports converters, validators. We have the same aspects there. We just don't support the JFace stuff because they are relying on viewers, viewer cells, viewer columns, whatever, everything related to JFace viewers, and we have no dependency to JFace at the moment. So there is no support at this stuff at the moment, but we will have a look at this. What we have instead is glazed list support. Have you heard about glazed lists before? Who knows glazed lists? Nobody? Okay. Glazed lists is a list implementation. It fully implements the collections API, and it was very popular with Swing because it is more performant than the native list API, and it comes with some features that are really fast. If you're looking into the source code, glazed list is open sourced, and it is provided by a really flexible license. That's why it's also at Eclipse. We are forced to use only license-friendly libraries, and glazed list has such a library. I don't know which one it is at the moment. Sorry. But if you're looking at the source code, they are doing really fancy stuff, really complex algorithms for special sortings, filterings, and everything. And they're adding support for trees. So the sorting can be used in NatTable without glazed lists, but I would suggest to use glazed list because it's quite fast. We are filtering with the filter row. I'm showing you in a showcase later on. With the glazed lists, so you can have regular expressions for filtering. And the tree is implemented with glazed lists. So you don't have to care about everything yourself. Just look at the glazed lists or at the examples provided by NatTable, and you're having a lot of base you can use for simply using or creating tables and tree views, tree tables with the NatTable. Okay. My project lead told me to, if you're talking about data access, show them the interfaces. These are the interfaces for a data provider, and this is what I tried to explain before. Your data provider is getting the column index and the row index and is then able to access the data. So it is possible to have a two-dimensional array as base, or you can use the list data provider who will just transfer the row index to the index in your list, will then call the column accessor with the row object. As you have a list data provider, it gets the row object, moves it to the column accessor and tells the column accessor, now give me the value for the column. So the interfaces for the iColumn accessor and iData provider are really simple and really easy to use. So the next thing on it, I will just, oh, I'm good in time, I guess. I'm having some examples at the end, so we can have some discussions on there too. The next thing, we are using some sort of config registry in the NatTable where we are configuring everything. So you can configure the styling. How should every column be styled? How should the column header look like? And everything. So the styling is done in the config registry and the bindings are done in the config registry. Bindings means we are supporting completely key bindings and mouse bindings if you're clicking into the NatTable, or if there is any other event, you're doing a right click, there should be a context menu or something like that. Everything is provided by NatTable, and you're doing this with bindings, key and mouse bindings. No data bindings, but key and mouse bindings. And one other really interesting thing is the conditional configuration you can do by labels. This means that you have to attach an additional processor. It's the label accumulator interface, where you're checking your cell values or your columns or whatever and attaching labels for your specific cases. I'm showing some examples on that. If you remember the risk matrix from before, we had some yellow fields, we had red fields and green fields, and they are styled by labels. I'm showing this, I guess this is quite confusing at the moment if I'm only telling this. So what functions are supported by NatTable? I tried to put all of them here, but that's not all here. We have context menus, as I just told you. On right click, there you open some menu box. Also relied on which cell you are currently in. Custom bindings and commands, as I told just before. We have column reordering, column height show. Well, nothing special at this moment. We have an Excel export with Apache Poi. Selections are included. You can create simple tables, grids, and trees. That's really important for most of the people. You can group columns. Well, no special feature, column grouping. You can't do this with JFace tables, but every table widget that comes shows up with column grouping. And we have also row grouping. This is a feature I haven't seen before in any table. We have the blinking updates. This is some example I'm showing you. The blinking updates will show the cells are blinking if the data in the back has changed. So with property change events, we can handle property change events. We have a summary row. We have column freezing, which is also a feature I haven't seen before. Normally, if you want to have 3 columns of your table fixed and the rest can scroll, you were forced to create 2 tables and attach them to each other so they are independent from each other. You don't have to do this with the NatTable because we are supporting freezing. You're just, like in Excel, you're saying, hey, fix these columns, and then you can scroll your table, but these 3 columns will stay. Filtering, the conditional styling, sorting, of course. Editing, we have a lot of editing support with combo box editors. We have editing rules, so you can decide if your cell should be editable or not by your own custom rules. So it is also possible to enable and disable the editing of your table cells by setting a flag anywhere in your application. I've done this in some of my applications. And the percentage sizing is a quite new feature for smaller tables, which I use in the log viewer. So what's the next thing? Okay, so now I'm showing some examples in the NatTable. We have seen this here before. Yeah, nothing special on that because that's a JFace table. If you're having a look at the NatTable, it's the same stuff. You can edit texts. You can have a checkbox. You have a combo box. Also nothing special in here. You have the sorting. And this is the first example I wanted to show you. The log view with different row heights. I didn't add selection. Why? I'm not sure. You can also see I have styled these with these icons, the warning icon, the error icon. We have different row heights, and this table is percentage sized. So if I'm lowering the view, or I'm lowering the window, the cells are moving like you're expecting it from Excel. In fact, we have an additional feature compared to Excel, because Excel only grows its rows. It's only getting bigger, but it doesn't get smaller anymore. We're supporting that too. At least I've written this feature so it shrinks, and it will be contributed soon. Just have to check it in, of course. That's one thing. Another thing is, has anybody of you worked with NetBeans before? Do you know NetBeans? Do you know the NetBeans resource bundle editor? I have seen this 10 years before, and since then I'm waiting in Eclipse to have that editor. And with NatTable, I tried to contribute this, and I'm still working on it to have the complete IDE integration, but at least what you're seeing here is such a resource bundle editor. The resource bundle editor is based on a table, of course. Resource bundles are key value pairs. You all know resource bundles, I hope? Yeah, okay, that's good. So we have key value pairs, and every key value pair is in another file. As you can see here, we have DE for German and EN for English and French. As you can see, I'm not a French-speaking guy. And the default properties. And when I want to edit resource bundles, I want to edit them all in once. That's the use case of this. I don't want to open every file itself and adding the same key value pair by itself. That's really annoying if you're working with resource bundles. And NetBeans had this editor 10 years before. So it loads all of the property files, put them together in one table, and so I have the direct visualization where I have missed to enter a value for a key or not. Nothing special at this moment. We have sorting as before. We can edit something in here, also no problem. We can filter. I guess I don't have the regular expressions enabled there. There are 3 possibilities to configure how your filtering should work. I guess there is the text matching mode active. There's also a regular expression mode, which is quite useful if you're having large tables that are showing numbers. Only show numbers between 50 and 80. And this is supported by the glazed list filter. Therefore, we are supporting regular expression filters in our filter. Do I have, yeah, you can see on right click, you can see my context menu that is added to the column header. So I can say clear all filters, and it is removed, or I can toggle the filter row so it is not visible. Guess what, Alt 3? No, not sure. There are also some key bindings we added to the whole table you can use out of the box. Well, this is some special feature I added here. The typical user use case. You're editing in your table, and then there should be created a new row where you can edit another row and another row instead of right-clicking and add row and writing in it. But what is more important in here is that this table supports a tree. So you're asking where there is a tree. Well, yes, I can switch the view. Now there's a flat hierarchy, so we don't have a tree in here, and now I'm enabling my tree structure, and I'm having a fully functional tree table where you can expand and collapse nodes. That's my second one, and there's, if you want to get more familiar with some of the features of the NatTable, we have created, well, here it is called the NatTable examples view. It looks familiar for those guys who have seen the JavaFX ensemble. We have just created a lot of examples where you can just have a look what we are providing. For example, we have a freezable grid layer. How many rows are there? It's 20 columns for 1,000 rows. And you can see it's quite fast. I hope you see it. And there, what is it? It is Control-Shift-F. And now freeze the left 2 rows. And as you can see, they don't move. And we have, well, we have a tree grid example, but I think my tree example is a bit more visual. We having styling, a styled grid, so you can completely style. Now it looks a bit more than a native table with the column header styled. And yeah, the selection is green. Is there anything custom style specific? Yeah, you can. This is an example for the conditional styling. So this is custom styling of cells. I wanted to show you the code to get the conditional styling with labels a bit more visual. Custom styling. I should. Applying styling to a cell. Is it this one? Looks like. It's a different one, but okay. This is the cell label accumulator I talked about, and you can tell the configuration or the cell label accumulator that every time in a cell there's a value with AAA, at the second column he will attach the cell label. No, it's not this one. Then it's the style. No. I'm not sure where it is. I will find it later. No, I'm really curious where it is. Configuration. Damn. Yet. There it is. It's not editable. Sorry for that. But as you can see, we applied some rules. Or we applied this rule to our NatTable, telling whenever there is a AAA in my rating column, show it red. And if it's updated in the back by any background processes, or if it's updated by editing or anything else, you will get this visualization automatically with this label registration. You don't have to do there anything manually. It's just out of the box. And what is there? What else is there? There's one thing, the text painter examples. That's something I'm really proud of because I've done a lot of this. How you can put text to your table. There are some. We have line wrapping. We have automatical sizing. So your column is growing if the text is getting longer, or you can configure it to wrap if you have a fixed column width, then the text will wrap, like you've seen here or there. This is just an example for gradient background painting, and something that is really interesting. I didn't know that. It's quite hard to implement underlined text in a JFace table. It's nearly impossible. I haven't found a solution for this. We had this request, and I thought, hey, okay, there's a font. Should have a style bit. No, it hasn't. I was searching and didn't find any solution. or quite suitable solution. So I was quite happy that I could say, hey, I'm a NatTable committer. We're custom painting the table. If I want to underline anything, just paint it. And so I added the underlining and strike through, and also the vertical text painters you normally use for larger tables where you have small column values, but the column header is quite long. You will write it vertically. So these are all paint options you can use in the NatTable out of the box. We're supporting this. Also tooltips. It's quite simple example, just looking at the cell position and printing it out. And there are a lot of more of these examples. We have also error handling. You can configure if you simply want to show, hey, it is red. If the value is not valid, you can configure the column 2 has a dialog error handler, so it shows red, and when I'm trying to enter, there's opening a dialog, as you know it from other rich applications, and you can tell if you want to change it or if you want to discard the value. Yeah, and this is the everything but the kitchen sink example. You can see we have there 52,000 lines of code. We have 40, is it really 40? I guess so, 40 columns. We have column grouping, and as you can see it, hopefully, yeah, there it is. Blinking updates, there's a background mechanism who randomly updates some data, and these are visualized in the table. This is everything you're getting out of the box if you want to use NatTable. Okay, now let's finish. So these are the functions. As I said, NatTable is still an active project. We're still working on it. We really like it. Everyone who's working on the NatTable likes to use it. It's cool, yeah. But we're still uncomfortable with some features. There's one thing, smooth scrolling. We are working on this for quite a while. If you're looking on how I scroll, it's also always one column switching or scrolling. This isn't very nice. If you have a too long column, then you're not possible to scroll that column. It doesn't work. But we had some requests to improve the scrolling, to enable smooth scrolling, and it is implemented. We need to do some improvements, I guess, and we will release it with the next version of the NatTable. There's one thing we all are very uncomfortable with. That's the configuration of the NatTable. As you have seen, it's a huge framework. You have a lot of layers. You can add labels. You can enable editing and everything. And yeah, if you're starting with a NatTable, it's a quite hard learning curve. Learning curve? Is that the correct word? I don't know. I hope you understand what I mean. And it's hard work to get it running the first time, because you have to add your layer composition. You have to configure how the layers are stacked up. It's all done programmatically at the moment. But as we don't like it, we're thinking of some processes to simplify these configuration efforts. And we are working on that. Don't know what is coming to the next release. Possibly the styling will become a bit more comfortable than it is now. There are also some refactorings of groupings. It's some nasty stuff in code. We want to refactor to make it smoother. And some further enhancement and bug fixes, like the shrinking of rows I showed before. This is definitely something we want to add to the next NatTable release. To our release cycles, I have to say that we are planning to release every quarter. So there will be 4 releases of NatTable per year. This is, compared to other Eclipse projects, a lot. There are a lot of projects or Eclipse projects that are having less releases. And we, at least in Nebula, I don't know if they're planning any releases currently. Sorry, Wim, if you're seeing this. But we have the plan to release 4 times a year, so every bug fix and new feature is provided to our users in a certain kind of time. But that's not all. We are planning some major refactoring on the NatTable. It's currently listed as a Nebula NatTable 2.x, and we're doing some brainstormings at the moment. At the EclipseCon, I showed another slide here where I said, hey, we want to add Eclipse 4 dependencies and everything else, and yeah, they were throwing stones at me. Why you want to add a hard dependency to E4? And I understand the fact, because if we are adding the hard dependency to E4, then you can't use NatTable anywhere else. So what we want to do there is, of course, no, this is the most important one. We want to add dependency injection, which will lower the configuration efforts for a NatTable instance a lot. Will make the life much easier when working with a NatTable. And if we're making it dependency, we're adding dependency or injection, or at least adding dependency injection support, then it would be an easy one to add Eclipse 4 support, or Spring dependency injection container, or Juice, for example. Yeah, JFace data binding, as I said before, is something we are thinking about adding some support on this. I also talked to Jonas Helming yesterday about EMF-based configurations. Well, we want to add the support and not change the configuration completely to only use EMF, but in some cases it would be nice to have a simple XML file configure, hey, this is my layer configuration, and now run, and I have my NatTable, and I don't have to care of every dependency in my layer stack by myself. This is the big picture we are having. Not sure how to do it yet. It's still in a planning phase where we're analyzing what we want to do and how we want to do this. And there's two things. This memory improvements is something Tom Schindler told me, the currently maintainer of the Nebula grid. Some things like, if you're scrolling images out of the visible part, then the images should be disposed to free the memory. Something we will surely look at. And there's one feature in the K-table we don't support yet, and that is multi-level trees. So you can, if you have a tree view, normally you have your tree column at the first place, and everything else is related to that. And K-table supports that you have in your tree view, there's a second level at column 5 where you can have where you can expand additional lines, so you can have multiple expand collapse levels. But there was one request, so we don't know how to do and when to do, not sure. And one thing that might become very interesting, and we were asked about that at the EclipseCon a lot, is about the rendering. Currently, we're custom painted. We're painting on a canvas. And so, yeah, it's currently a quite hard dependency to the SWT canvas. We can just paint on a SWT canvas. But as we are simply painting, there's canvas in HTML5. I heard of Wrap is supporting canvas in HTML5. I'm not sure. I haven't looked at Wrap lately, so I'm sorry for not having any detailed information on that. And I talked with the guys from Canoe about JavaFX canvas, and they told, hey, yeah, it's perfectly fine. If you're using canvas, then just paint on the canvas. And this is something we definitely want to look at to support different renderings. So you could also use the NatTable with all of its features in another platform. So you can use a NatTable for JavaFX to have a enterprise-ready table in another platform. These are the base ideas we are having. So I'm running out of time, and I'm finished. Yeah. You can have a look for further informations. You can have a look at our website. We just moved it, and I'm the one who's writing the documentation there, so there's still some parts missing, but don't hesitate to talk to me. If you're missing some documentation, I will add it. We are quite active at the NatTable forum, so if you have any questions, if anything isn't working correctly or you don't know how to do it, just open a topic at the NatTable forum. I will try to answer in time. We have also a mailing list you can write on if you have some specific questions. And I've also released some articles written in German to give you an introduction on the features of the NatTable, how to get started. There are also some example projects to give you a startup help. So that's it. Are there any further questions? No? So thank you. And have a nice W-JAX.